Right, so this is the second subtopic of number system. So today we are going to learn about complex number. Okay, so before this we have learned about the real number, and the thing is, real number is actually the subset of complex number. So complex number is actually a bigger set of numbers compared to real numbers. So complex number can be written in the Cartesian form, z equal to a plus bi. So this is actually known as the Cartesian form. So Cartesian form. Okay, so what is a? A is actually the real part. And what is bi? So bi is actually the imaginary part. So a complex number consists of two parts, one real part and one imaginary part. Okay, so this I, so this symbol I here is an imaginary number where I is actually the square root of -1. As you can see, I told you before that z equal to a plus bi. This is actually in Cartesian form. So that means if let's say after you doing some multiplication or addition, if let's say you do end up with I square, I cube, I to the power of 4 or something else, you should be able to simplify them. Okay, so for example, I square over here. So I is equal to the square root of -1. So that means if I square the left hand side and I square the right hand side, I will obtain I square equal to -1. You have to keep in mind about this because we will use them later on. Okay, so I cube is actually I square times with I, and I square we already have them over here, which is -1 times with I. Therefore, what do we have is simply negative I. Okay, so now I to the power of 4, so this is actually I square times with I square. So this is actually -1 times with -1, and if you times -1 with -1, you should be able to get 1. Okay, do remember, keep in mind, if you have I to the power of something else other than 1, make sure to simplify them first. Okay, so now operation of complex number, we can actually do some operation for the complex number. We can do some addition, we can do subtraction, multiplication, as well as a division. But for division, there's a catch somewhere here, but I'll let you know later on. Okay, so let us proceed with the addition. So for example, if let's say we have 3 plus 2i plus with 5 plus with 3i, so we have to collect like term. So those with I, those without the I, we're gonna add them together. So 3 plus 5, so adding the real part, 3 plus 5, and then plus with 2i plus with 3i. So real part with real part, imaginary part with imaginary part. Okay, so 3 plus 5, 8, plus 2i plus with 3i, so this is 5i. So that is how we do an addition. So now subtraction. So similar question, except that now I change the plus to minus. Okay, so real part with real part, we're gonna have 3 minus 5. And then plus with, so 2i minus plus, so this is minus 3i. So simplify them, we're gonna get -2, -i. Okay, so that is subtraction. Now multiplication, be very careful with multiplication. So let me multiply the 3 first. Okay, so 3 times 5 first. So this is equal to 15. 3 times with 3i, so this is 9i. So we have 2i. Okay, so 2i times with 5, so this is plus with 10i. And then 2i times with 3i, be careful, so 2 times 3, so this is 6. But I need to times with I, so you have to add the power, so this is I square. So what do we have is actually 15. 9 plus with 10, so this is 19i, plus with 6i squared. Okay, so like I told you before, in Cartesian form, the highest power for I should be I to the power of 1. So other than I to the power of 1, we should simplify them first. So we already simplified I square previously. So I square is actually -1. So what do we have here is 15 plus 19I plus 6 times with -1. So we're gonna have 15 minus 6. So this is 9 plus with 19I. Okay, so done with this. So the next one, a division. Okay, so a division, that means you're gonna have your I at the bottom, or at your denominator you're gonna have some I. So what we should do is that we need to multiply with the conjugate of our denominator, because I need to make sure I get rid of the I at the bottom in order to write them down in Cartesian form. Okay, so how do we find the conjugate? If let's say we have z equal to a plus bi, then the z bar or the z conjugate is simply a minus bi. So what is the conjugate? You're gonna keep the real part, but for imaginary part, we're gonna flip the sign. So plus will become minus. If we have minus, it will become a plus. So this is because of the reflection along the real axis. So that is why we have to flip the sign only for the imaginary part. Okay, so now we have 5 plus 3i. So we're gonna keep the real part. So I'm gonna multiply with 5. Positive 3i, I'm gonna flip the sign. So it will be negative 3i. Okay, so you shouldn't simply multiply with 5 minus 3i, because you're gonna change the question. So times them with 5 minus 3i over 5 minus 3i. Okay, so what we will do is that I'm gonna expand my numerator, and then I'm gonna expand my denominator as well. So let us expand our numerator. So we got 3 times 5, so this is 15. 3 times with negative 3i, so this is negative 9i. Positive 2i times with 5, so this is positive 10i. Positive 2i times with negative 3i, so times the sign first. So this is negative 6i squared over, okay, so 5 times 5, so this is 25. 5 times with negative 3i, so this is negative 15i. 3i times with 5, so this is positive 15i. 3i times with negative 3i, so that is negative 9i squared. Okay, so now let us simplify them a little bit. I do see something that can be simplified over here. Negative 15i, positive 15i, those two will simply cancel out each other. And then, as like I told you before, for Cartesian form, the highest power for I should be I to the power of 1. But I do have something with I square and I square here. So we should simplify this. So I square is actually negative 1. This is negative 1 as well. So what do we have is 15, negative 9, positive 10. So this is positive I. And then negative 6 times with negative 1. So this is positive 6 over, so 25. Negative 9 times with negative 1. So this is positive 9. So what do we have is 15 plus 6. So 21 plus with I over 25 plus 9. So this is equal to 34. Okay, so in order to write them down in Cartesian form, I have to separate the fraction. So this is 21 over 34 plus with 1 over 34i. Okay, so I'll see you guys in the next part. Bye bye.